Hello guys, this is the 11th lecture of chemical kinetics. In the previous lecture, we have talked about the integrated law and half-life and the graphs of second, third and fourth order kinetics, that is nth order kinetics, and we have calculated general expression for nth order kinetics, and this come out to be this one, that is t is equal to time is equal to 1 upon n minus 1 into k into multiply 1 upon a ki power n minus 1 minus 1 upon a naught ki power n minus 1, where a is your final concentration, that is concentration at time t, a naught is initial concentration, and n is order of reaction, rate, k is rate constant. So, and then we have solved for half-life of the nth order kinetics, and for nth order kinetics, the half-life come out to be this one. T half is equal to 2 to the power n minus 1 divided by n minus 1 k into a naught to the power n minus 1. And we have said the time and the rate law for nth order kinetics and the T half equation is only valid for n greater than or equal to 2. But if we see T half, we can see T half is directly proportional to A naught ki power 1 minus n. It is 1 minus n, not n minus 1. So remember it very carefully, because lot of guys forget what is the power of initial concentration in T half. It is 1 minus n, not n minus 1. Okay. So this equation is valid for even zero order and first order reaction. So in today's lecture, we will try to solve or try to find the order of reaction using different methods. And the methods, actually we are actually talk about all the method. So we will solve using 2 or 3 methods today. So topic is different methods to find order of reaction. Different method to find order of reaction. And here we will talk about first half-life method. Second, we will talk about graphical method. And actually, when we talk about zero order, first order, or nth order kinetics, that is in the previous lecture, we talked about all the graphical graphs of each order of reaction. So this is actually covered, but I will give you a essence how to get order of reaction from the graphs. Third is integrated rate law method, which is also called hit and trial method. So for this type of question, which is solved from the integrated rate law, we know the integrated rate law of zero and first order kinetics. And for higher order kinetics, we know the general expression. From general expression, we can have integrated rate law of second order, third order, and fourth order kinetics. So for this type of equation, you will have some data. They will give you more than 2 data. From that data, you have to make 2 equation. From that 2 equation, you will get K1 and K2, that is rate constant of the equation of the reaction. And if the rate constant is same, then you will have you will guess this right rate law. If the rate constant is different, and then you have to choose another rate law to get the same rate constant. So Actually, this is a hit and trial, and it will be a cumbersome if you are not getting the guess correctly in the first iteration. So then initial rate method. Uh, this method I have actually covered in the lecture 3, I guess. Actually, before that lecture, I have already covered the rate law expression or rate expression. So we need only the rate expression to solve order of reaction or to find order of reaction from the initial rate method. So that's why we have covered initially in the third lecture this method. So this is actually covered. So we will talk about these three methods in today's lecture. Now first is half life method. Now start करते हैं half life से. Half life method. So what is the half life of zero order reaction? Right, for zero order reaction, first order reaction, zero order, first order, and first order and second order. Second order. So for zero order, T half is equal to A naught by 2K. And for first order, T half is equal to 0.693 by K. And for second order, T half is equal to 1 upon K A naught. Okay. So if we write here in the proportional term, T half directly proportional to A naught. T half does not depend on A naught, and T half directly proportional to 1 upon A naught. So from all three terms we get T half is directly proportional to A naught to power 1 minus n, and this is, I have already covered this equation in the previous lecture, and we will use this equation to get the or to solve the questions. So here n is order of reaction. Order of reaction. Okay. So how question will came for relating the T half? So question will be like this. If I take an example, you have given an initial concentration that is A naught in molarity, and you have given half life that is T half in minutes. So you will given a two data here, A1, T1, A2, and T2. So initial concentration is A1 of reaction. Let's consider this A to P. Initial concentration is E1 and half-life T1. Initial concentration is A2 and then half-life T2. If this type of data you have given, so you have to use equation T half is equal to, no, T half is directly proportional to A naught to power 1 minus n. So if we use these two data, then T1 is directly proportional to A1 to power 1 minus n, and T2 is directly proportional to A2 to power 1 minus n. We have these two equations. If we divide 2 in equation number 1, then we have T1 by T2 is equal to, because it is proportionality counter, will be converted into the equal to, and then we have A1 divided by A2 to the power 1 minus n. So we have a relation between T1 and T2, and T1 divided by T2 is A1 by A2 to the power 1 minus n, and we have to use this equation to solve all the question related to half-life. So first of all, how do we know we have to solve a question using half-life method, graphical method, integrated rate law method, or initial date method? So you have to determine what are the data given. If data given in terms of half-life, use half-life method. If data given in terms of uh, rate expression or initial concentration rate expression, you have to use the initial rate method. If data given with concentration, not initial concentration, is concentration and time, not half-life, not initial concentration, in the concentration of reactant and time, then you have to use integrated rate law method. And if the equations given in the graphical manner, then it is very simple that you have to use the graphical method to know the order of reaction. So now let's do some question related to half-life. Question number 1. So question is the half-life of a decomposition of a compound of a decomposition of compound is 20 minutes when the initial concentration is double. When the initial concentration is double. When the initial concentration is double, half-life reduces to half-life reduces to 10 minutes. Find order of reaction, and the options are given 0, 1, 2, 3. This order of reaction given. So solution. पहले देखते क्वेश्चन में क्या दिया है. क्वेश्चन में दिया है कि जब इनिशियल कंसंट्रेशन में हाफ लाइफ जो कंपोजिशन की 20 मिनट है, और जब कंसंट्रेशन को हम डबल करते हैं तो हाफ लाइफ आपकी 10 मिनट रह जाती है, घट जाती है. तो यहाँ पर हम डेटा बना लेते हैं. इनिशियल कंसंट्रेशन, let's consider it should be A naught, and half life it should be T half. So जब A naught कंसंट्रेशन था तब 20 मिनट थी, यहाँ लिखते हैं इन मिनट्स. और जब A naught बाय जब 2A naught हुआ, when the initial concentration is double मतलब 2A naught हुआ, then half life is 10 मिनट. ठीक है, तो हमने पीछे एक फॉर्मूला डिराइव किया था, वही फॉर्मूला यूज करते हैं. इसको मान लेते हैं 1, इसको मान लेते हैं 2, तो A1 A2. So T1 by T2 is equal to A1 by A2 की whole power 1 minus n. So T1 is your 20, T2 is 10, A1 is A naught, and A2 is 2A naught, and to power 1 minus n. A naught to A naught cancel out. This is 2, this is 1 by 2, the whole power 1 minus n. 2 की power 1 is equal to 2 की power n minus 1. Actually 1 by 2 is 2 की power minus 1 minus n. So minus 1 minus n is n minus 1. So we will compute it. So n minus 1 is equal to 1. So n is equal to 2. We get second order. So C part is correct, and this is second order reaction. Now take another example. Question number 2. For a gaseous reaction For a gaseous reaction, the initial pressure and corresponding half-life data is shown. Half-life data is shown. Find order of reaction. So data है आपका pressure which is in kilopascal and half-life which is T half in minutes. Data is 100 kilopascal pressure में T half है आपकी 105 minutes. 66.66 kilopascal में है 235 minutes and 33.33 में है 950 minutes. ओके, तो ये आपका डेटा गिवन है और ऑप्शंस हैं वही 0, 1, 2, 3. तो सॉल्यूशन. Now try it on your own. Pause the video and try it on your own first. Then I will try. So in this question, you have given an initial pressure in term, instead of initial concentration. So reaction is, since reaction is in gaseous phase, so initial concentration is replaced by initial pressure because reaction is in gaseous reaction or gaseous phase. So you can say this pressure is actually an initial concentration. Okay, so we know the formula is same. T1 by T2 is equal to A1 by A2 because this is double of this. So mathematics is this. So mathematics is simple if we take this data instead of this. So I will take this data. So we have T1 is 235 and T2 is 950. A1 is 66.66. A2 is 33.33. 33 the whole power 1 minus n. Now divide by 5. 4, 7, 1, 9, 0. This is 2. So this is 47 divided by 190 and this is to the power 1 minus n. 47, this is not divisible, divide. So what is the 47 times 4? 47 times 4 is 82188. So actually it is closer to 188. 190 is closer to 188. So we will take 47 divided by this. It comes out to be 1 by 4. So 1 by 4 is equal to 2 to the power 1 minus n. So I will solve here. 4 की power minus 1 is equal to 2 की power 1 minus n. So 2 square की whole power minus 1 is equal to 2 the power 1 minus n. So 2 की power minus 2 is equal to 2 की power 1 minus n. So 1 minus n is equal to minus 2. So n is there. 1 plus 2 is equal to n. So n is equal to 3. That is third order reaction. Option is D part. Here this is third order reaction. So actually, if you see the option in this question, all options are integer type. So we don't have any option that are in fraction. So we have to take approximation that this is actually 1 by 4, not less than 1 by 4. So the reason behind it is these all data are experimental, or in experiment you may did some mistakes. There are some 1 plus 2 plus minus 2% of error in the experiment. So from that point of view, it should be 188 and it should be 1 by 4 actually, but you will get not 1 by 4 because the timing of taking data uh, is very difficult to have a zero error in experiment. So why take that consideration in mind. So we have integer type data and this is equal to n is equal to 3. Now let's take another very important question. So question is similar to previous question, that is for a gaseous reaction. I have just written the for a gaseous reaction. Uh, uh, Everything is same. Initial pressure corresponding to half data is shown. One order of reaction. Okay, just I've given you the data. Initial pressure, which is in kilopascal, and half life, which is in minutes. So data are 700 kilopascal, half life is 84 minutes. 430 kilopascal, half life is 83.5 minutes, and 104 kilopascal, half life is 84 minutes. Find order of reaction, and option is 0, 1, 2, and 3. Now do it by your own. Watch the video and get the answer. And then check you are right or not. So now I will going to solve it. First look at the data. From data you can see initial pressure is 700 kilopascal, half life is 84 minutes. Initial pressure is 430 kilopascal. The change in initial pressure is very much high. Half life is 83.5. Initial pressure is 700 and 104. Actually, there is a lot of change in initial pressure, but half life is constant 84. So if we don't take this data, because it is only a difference of 0.5 minute, and 0.5 minute is actually 30 seconds. So you may have error in the experimental data. It should be 84 minutes. So from data you can see half life does not depend on the initial pressure. By the data we can see we can see half life does not depend on initial pressure. What does it mean? It means reaction is first order. Reaction is first order, because for first order T half is 0.693 by K. It does not depend on the initial concentration. The answer is V part, that is first order. And if you want calculation, so do the calculation. I will take this and this data. T1 by T2 is equal to A1 by A2 whole power 1 minus n. So T1 is 84, T2 is also 84, A1 is 700, A2 is 104 to the power 1 minus n. This is 1 and this is 175 by 26 divided by 4 the whole power 1 minus n. This only equal to 1 when the power of 175 divided by 26 is equal to 0. So this implies 1 minus n is equal to 0. So n is equal to 1. So first order reaction. So you can solve it, but why to waste time by solving it if you can get from the data. But for a board exam, you have to solve it. But for a competitive exam, just take mark the answer if this type of data is given. If half-life does not depend on the initial concentration, just take the first order reaction. Now we will talk about the second method, that is graphical method. Second method is graphical method. If the graph is reactant concentration, reactant is constant, concentration or logarithm of concentration or 1 upon concentration or 1 upon concentration square dash 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 1 upon concentration to the power n minus n minus concentration to the power n minus 1 versus time, this graph given, then we know what type of order of reaction should be there. So let us consider if the graph is this. That is your concentration of reactant with respect to time, and it is a straight line with a negative slope. Then what is the order of the reaction of this graph? It is simple, that is zero order reaction. Zero order reaction. And if the graph given logarithm of concentration with respect to time, and this is also a straight line with a negative slope, then y-axis is different, it is logarithm, then it means it is a first order reaction. If the graph is 1 upon concentration of reactant with respect to time, and it is given a straight line with a positive slope, then it means second order reaction. Second order reaction. And if the graph is 1 upon concentration to the power 2 with respect to time, and it is a straight line with the positive slope, then it means it is a graph of third order reaction. And if the graph is 1 upon AQ with respect to time, and it is also straight line with a positive slope, it means fourth order reaction. Actually, from the graph, we know what type of graph will be there for which type of order of reaction. So the question with respect to graphical method is very straightforward. There is one question came in JEE mains. Question is like P plus Q give any product, and it is written for P T75% of P, it is equal to 2 times of T 50%. This is given for P, and for Q the graph is this. For Q versus time, the graph is this. So just you have to tell what is the order of reaction. So here we know if T75 is 2 times of T half, if it is T100 is 2 times of T half, then it is a zero order reaction. But T75 is 2 times of T half, it means it is a first order reaction, first order with respect to P. And for Q, we have a graph of concentration of Q with respect to time, it means we have zero order with respect to Q. So total order of reaction is equal to हो जाएगा 1 plus 0, that is 1. So total order of reaction for this equation is 1. So that is how we can solve question related to graphical method. Now we have one more method, that is integrated. Third method is your integrated rate law method, or we can say hit and trial method. So for this type of question, we have a data, we have at least 3 datas, and the data will be like this. You have given a concentration and time, and you have at least 3 datas. 1, 2, 3. At least 3 data you have for this type of equation. This is the this type of graph. It will be there in the question. So what should you have to done for this question? Actually, it is given a initial concentration with respect to time. Then you will use initial rate method. Oh no. Initial rate method, you have to use initial concentration with respect to rate of reaction. Then you use initial rate method. If it is initial concentration with respect to T half, then we use half life method. If you have given any graph, then you will use graphical method. But if you have given a concentration of reactant and time data, then you have to use the integrated rate law method. So the idea of integrated rate law method is that first you have to assume or check first order. First you have to assume first order or check first order. So for first order you have T is equal to 2.303 by K log A naught by A. So convert it in rate constant. So K is equal to 2.303 divided by T log A naught by A. Then use any two data. Let's consider this, and then this and this. Use any two datas to find two values of K. So use any two data and make two sets and make two sets. Then check the values of rate constant since equation and since reaction is similar, A gives product, so rate constant will be same for this type of reaction because there is only one reaction, or you are not changing the temperature and pressure of the you are not changing the temperature of the reaction. So rate constant will be same. So check the values of rate constant is same or not. If yes, then reaction is first order. If yes, then reaction is first order. Else we will assume zero order reaction. Then zero order reaction लेके उसका इक्वेशन लिखेंगे A is equal to A naught minus KT, then K is equal to A naught minus A divided by T. तो यहाँ से आपका वैल्यूज ऑफ K निकलेंगी. Find values of K if same to zero order reaction, else लीजिए सेकेंड ऑर्डर, एज्यूम करेंगे सेकेंड ऑर्डर. फिर सेकेंड ऑर्डर का आप इक्वेशन लिखेंगे. इक्वेशन आपका आएगा K इज इक्वल टू 1/t 1/a माइनस 1/a0। फिर ऐसे ऐसे करते करते अगर सही है तो आपका सेकेंड ऑर्डर हो जाएगा, एल्स थर्ड ऑर्डर, ऐसे करते करते चलता रहेगा। ओके। तो पहले हमने फर्स्ट ऑर्डर क्यों चेक किया और दूसरे हमने जीरो ऑर्डर क्यों चेक किया, क्योंकि 99% ऑफ टाइम क्वेश्चन जो पूछा जाएगा वो फर्स्ट ऑर्डर और जीरो ऑर्डर से ही पूछा जाएगा, हायर ऑर्डर से नहीं पूछा जाएगा। क्योंकि इंटर के कोर्स में हायर ऑर्डर के ज़्यादा क्वेश्चंस है भी नहीं और ज़्यादा अच्छे से उसको समझाया भी नहीं गया है। तो आपके कोर्स में फर्स्ट ऑर्डर जीरो ऑर्डर इरिक्शन है, तो आपको चेक करना है फर्स्ट ऑर्डर पहले देन जीरो ऑर्डर। एक्चुअली क्वेश्चन फर्स्ट ऑर्डर से ज़्यादा होते हैं, तो इसीलिए फर्स्ट ऑर्डर को पहले चेक करेंगे। भाई जब पता है कि आपका क्वेश्चन का आंसर क्या है, तो क्यों नहीं कि हम पहले उसी से चेक करके टाइम बचाया जाए, क्यों जीरो ऑर्डर चेक करें। तो वही चीज़ है कि पहले फर्स्ट ऑर्डर से चेक करेंगे जिससे कि आपका टाइम सेव कर सकें। और अगर फर्स्ट ऑर्डर नहीं आता है तो आप फिर जीरो ऑर्डर से चेक करेंगे। ठीक है। तो एक मैं एल्गोरिथम इसको एक इन टर्म्स ऑफ एल्गोरिथम में भी इसको दिखा देता हूँ कि एल्गोरिथम क्या करना है। तो एल्गोरिथम इसकी होगी, यहाँ पर सबसे पहले आएगा आपका एज्यूम फर्स्ट ऑर्डर। जब फर्स्ट ऑर्डर एज्यूम कर लिया तो उसका फॉर्मूला लग जाएगा k इज इक्वल टू 2.303 बाई टी लॉग ए नॉट बाई ए। देन यहाँ से आपके दो के आएंगे, फिर उन दोनों के को आप चेक करेंगे k1 इज इक्वल टू k2 और नॉट। अगर यस है तो आप प्रिंट कर दीजिए, यस है तो आपका हो जाएगा, जो आपने एज्यूम किया है वो हो जाएगा फर्स्ट ऑर्डर, मतलब जो भी एज्यूम किया आपने, राइट अजम्पशन। अगर ये गलत है तो आप पीछे जाएंगे और यहाँ से फिर से एज्यूम करेंगे दूसरा। आपको यहाँ एज्यूम करना है देन जीरो ऑर्डर। ठीक है, फिर जीरो ऑर्डर की काइनेटिक्स लगेगी, फिर जीरो ऑर्डर काइनेटिक्स लगने के बाद फिर Q1 इक्वल टू Q2 होगा। अगर यस है तो राइट अजम्पशन, नो है फिर आप सेकेंड ऑर्डर के लिए जाएंगे, उसकी काइनेटिक्स रेट लॉ लगाएंगे, फिर वो रेट लॉ से आप Q1 Q2 निकालेंगे। ऐसे करते करते जब तक K1 इक्वल टू Q2 नहीं आता है तब तक आप एज्यूम करते रहेंगे। तो ये आपका एल्गोरिथम हो गई हिट एंड ट्रायल की। तो एल्गोरिथम ऑफ इंटीग्रेटेड रेट लॉ मेथड। ठीक है, इससे रिलेटेड एक क्वेश्चन कर लेते हैं जिससे कि आपको थोड़ा सा अच्छे से समझ में आ जाए। क्वेश्चन करते हैं नेक्स्ट पेज में। तो क्वेश्चन है, इफ रिएक्शन गिवन है आपकी ए गिव्स प्रोडक्ट, ए गिव्स प्रोडक्ट, तो ए जो है कंसंट्रेशन ऑफ ए इन मोलैरिटी में एंड टाइम इन मिनट्स, ये आपको गिवन है। क्या क्या गिवन है, 50 है आपकी 0 मिनट में, 30 है आपकी 10 मिनट में, और 18 है आपकी 20 मिनट्स में। तो ये आपको डेटा गिवन है। तो आपको निकालना क्या है, फाइंड ऑर्डर ऑफ रिएक्शन। तो सॉल्व करिए आप अपने आप, और अपने आप सॉल्व करें, और बिल्कुल चीट मत करिए इसको, अपने आप सॉल्व करिए, देखिए आप सही आते हैं कि नहीं आते हैं। बिल्कुल जो ये एल्गोरिथम बताइए इसी एल्गोरिथम के द्वारा सॉल्व करिए। ये पहले आप फर्स्ट ऑर्डर को मानिए, फर्स्ट ऑर्डर का K1 K2 फर्स्ट ऑर्डर के थ्रू दो डेटा लीजिए, दोनों डेटा से K1 K2 निकालिए। अगर K1 K2 सेम आता है तो आपका अजम्पशन सही था, नहीं आ रहा है तो फिर दूसरा ऑर्डर लीजिए। ठीक है, तो हम लेते हैं फर्स्ट ऑर्डर। फर्स्ट ऑर्डर के लिए K की फॉर्मूला क्या होता है, 2.303 डिवाइड बाई टी लॉग ए नॉट बाई ए। तो हम पहले लेते हैं ये दोनों डेटा। तो K1 इज इक्वल टू 2.303 टाइम लगा 10 मिनट, log A नॉट इज 50 एंड A इज 30, काट दिया, तो K1 इज इक्वल टू 2.303 डिवाइड बाय 10 log 5/3. दिस इज योर फर्स्ट इक्वेशन. देन दूसरा डेटा के लिए हम क्या करते हैं, सेकेंड डेटा हम लेते हैं ये और ये. तो K2 is equal to 2.303, time is 20 minutes, and log 50 by 18, A naught by A. So K2 is equal to 2.303 divided by 20, log 2 से डिवाइड कर देते हैं, 25 divided by 9. So you can see 25 by 9 is 5 square by 3 square. So K2 2.303 divided by 20 log 5 square by 3 square. Now K2 2.303 by 20 log 5 by 3 whole square. This square came out from the log. So K2 is equal to 2.303 by 20 multiplied by 2 log 5 by 3 divided by 2. So this come out to 2.303 by 10 log 5 by 3. This is equation 2. And from the if first and second equation, you can see both are same. We get so from equation 1 and 2, we get K1 is equal to K2. So reaction is first order. Okay, this is how to solve this equation, and we have done. And the last method is your initial date method, and we have actually covered in the lecture 3. So to get order of reaction, all the method was covered. That is half-life method, graphical method, integrated Taylor method, integrated and initial date method, and all the order of reaction that are important are covered. That is zero order and first order, and for and nth order also covered. So in the next lecture, we will talk about the temperature dependence of rate of reaction. That is Arrhenius equation, and then we will have some more formulas there. Till then, okay, bye.